Okay, class, good morning. Let's have another problem in your next topic, which is the area computation using DMD method and the DPD method. DMD meaning double meridian distance, and then for DPD, that is double parallel distance. Okay, but before the problem, let's have the rules in computing the area using DMD or DPD. So to compute using DMD method, so rule number 1, the DMD of the first course is equal to the departure of the course. So for example, you have this departure, then DMD. So whatever is the value for your DMD of the first course is equal to the departure of the course. Okay. Next, rule number 2, the DMD of any course is equal to the DMD of the preceding course plus the departure of the preceding course plus the departure of the course itself. So therefore, the DMD of the next is equal to the DMD plus the departure equal to the DMD of the next. And then the DMD of the last course is numerically equal to the departure of that course but opposite in sign. Okay, so the DMD and the departure should be equal but opposite in direction. Okay, and then for the formula for the double area, you have the double area equal to the DMD multiplied by the adjusted latitude. To solve for the double area, you have the area is equal to 1/2 times the summation of all the double areas. Okay, that is for the DMD. For the DPD, you have for the DPD, that is the DPD of the first course is equal to the latitude of the course. Okay, so you have the latitude is equal to the DPD. Okay, and then the DPD of any course is equal to the DPD of the preceding course plus the latitude of the preceding course plus the latitude of itself. So you have the DPD plus latitude is equal to DPD plus the DPD itself. Okay, then the DPD of the last course numerically equal but opposite in sign. So the DPD is equal to latitude but opposite in sign. Take note, determining DPD is essentially the same as determining DMD. The only difference is that the DPD method, the lines are projected upon the reference parallel instead of the reference meridian. The same formula for the double area. You have DPD multiplied by the adjusted departure, and to solve for the area, you have area is equal to 1/2 times the summation of all the double areas. Okay, let's have the problem. In the accompanying tabulation, given the adjusted latitude, so you already have the adjusted latitude and departure of closed traverse, calculate the area using DMD and DPD method. So you have DMD and double area. So you have this drawn to scale sketch for the adjusted departure and latitude. Okay, so for line AB, you have 490, that is the latitude 490, and the departure is 47. Then for line BC, that is 500 587. You have the latitude, and the departure is 608.89. Okay, so that is how you draw the sketch for the given latitude and departure. Okay, so to compute for the DMD, this one refers to the rule. First is the DMD of the course is equal to the departure of the course. So therefore, DMD of AB, line AB, is equal to the departure of line AB. And then the next rule, you have, okay, let's have the rules. For the next rule, you have the DMD of any course. You have the DMD of any course is equal to the DMD of the preceding course. It's the preceding course plus the departure of the preceding course plus the departure of itself. Okay, so you have the departure of itself, the departure of the course, and the departure of the preceding course. Okay, so therefore you have Therefore, you have 47.87 plus 47.87 plus 608.89. Therefore, you have 703.43. Let's have the tabulation. Okay, so you have DMD 47.27, and then and then for BC, that is 703. 47.27 times 2 plus 108.89, 703.43. Next, so you have 703, that is your DPD, okay, 703. So the DMD of any course, you have 703 is equal to the DMD of the preceding. You have this DMD plus the departure, which is so this one, DMD plus departure plus this one. Okay, so the DMD of any course is equal to the DMD of preceding course plus the departure of the preceding course plus the departure of the course itself. Okay, so the DMD of the preceding course plus the DMD, the departure of the preceding course plus the departure itself. Okay, so therefore you have 703.43 plus 608.89 plus 786.78. So that is 2090.1. Okay, so next is that is 2090.1 plus 706.78 plus 208.32. Okay, so that is 3095.2. So next, 3095.2 plus 218.32, that is the DMD or departure of the preceding line, and then the departure of the preceding line, which is minus 1116.62. So that is positive 2196.9, and then 2196.9 minus 1116.62 minus 544.64. It should be equal to sorry, wrong calculation. 300 at 3,000, wrong calculation. 2099, 2099.1. Sorry. So 2099.1 plus 786.78 plus 218.32. So 3,104.2, and then 3,000 plus 218.32 minus 1116.62. That is 2,205.9, and then last is minus 1116.62 minus 544.64. Should be equal to 544 544.64. So the last DMD of the course is numerically equal to the departure of the course but opposite in sign. So the sign is negative since that is west departure, so that is negative. So here our calculation is positive. Okay, next we compute for the double areas. So for the double areas, you have the DMD which is 47.27 multiplied by the latitude, adjusted latitude, which is 490.71. So that is 23,195.86. So next for line BC, that is 703.43 times 5, adjusted latitude is 587.12. That is 412,997.82. Then next for a double angle for line CD, where the CD DMD is 2099.1 times negative 32 negative, since that is south latitude, negative 327.41. Okay, so that is negative 687,266.33. Then next, you have the DMD of line DE is 3104.2 times the latitude, adjusted latitude of line DE, that is 1002.76. So you have, by the way, that is negative. So you have negative 3,112,767.59. Okay. Then next is line EF. So you have the DMD, which is 2,205.9 times the latitude, which is negative, that is south, so negative 122.67. So you have your double area equivalent to negative 270,597.75. And last line, you have line FA, the DMD, the double meridian distance is 544.64 multiplied by the adjusted departure, which is 375.01. So you have your double area is equivalent to 245.45. So you sum it up, that is 23,195.85 plus 412,997.82 minus 687,266.33 minus 3,112,767.59 minus 270,597.75 plus 204,245.45. That is negative 3,430,192.54. So therefore, to compute for the area, that is one area, that is 1/2 times the summation of double angle, or that is 2 times area is equal to the summation of double angle. So therefore, you just have to divide it by 2. So 3430192.54 divided by 2. So you have your answer 1,715,096.27 square meters. So negative sign is disregarded since this is an area. Okay. So tabulated solution, you have the DMD and the north double angle and south double angle. Okay, so this is the answer. So to continue, let's have the area by double parallel distance, or DPD. So for the DPD, you have this calculation. So the DPD of the first course is equal to the latitude of the course. So this is the latitude of line AB. So equal to the DPD of line AB. Next, the DPD of the line AB is equal to the latitude of the preceding line plus the the latitude of the preceding line plus the DPD latitude of the course itself. Okay, so this is the latitude of the course, the DPD of the course, and then the latitude of the preceding course. Okay, so that is equal to 1568. Next, the DPD of line CD, that is the DPD of the course plus the DPD itself plus the latitude of the preceding course. Okay, so that is the answer. So you have 1822.25. Next, the DPD of line DE, that is 1828.25 minus the the latitude of line DE and the latitude of line EF. Okay, DE latitude and DE, CD and DE. Okay, so you have your DPDs, so you have the ruling, so you have the answer. Next is to compute for the double area. So for the double area, you have just the DPD multiplied by the adjusted departure. So same with the double area of the DMD, but that the formula is DMD multiplied by the adjusted latitude. For DPD, that is DPD multiplied by the adjusted departure. So you have your area, so just the same answer for the area. Okay, even if you have two different solutions, but you have the same answer in solving the area, and you have the tabulated solution for the